Hello, my name is Jeremy Clavette, and for my final project in solid mechanics, I am going to be studying the rotating disk of variable thickness. So, for my project, I will be using FEA to optimize the thickness profile of a rotating disk. Likely, I will be using COMSOL and potentially Abacus to perform the FEA. Um, Whatever results I obtain, I will validate with the analytical solution. Um, I've found various materials and literature online that provide analytic solutions for some various shape functions describing the profile of a variable thickness radial disk. And these are the results that I will be comparing my FEA to. Um, I would specifically like to look into the von Mises stress in these radial disks. Most of the literature that I've found online breaks it out into radial and hoop stress. And in the design world, this is for an aerospace application. Likely the most important um, output would be the von Mises stress criterion. So I would like to specifically look into the von Mises stress of these various thickness radial disks. I will be using some standard material properties for this work. Um, we have previously in homeworks and for this course, we have used a structural steel material with a Poisson's ratio of 0.3 and a density and modulus as listed on screen here. So I'll be maintaining consistency with that and using the values shown here. Um, if time allows, I may look into enforcing the mass of the system. Um, Not enforcing the mass, at least looking into the outputs in relation to their mass. As if this is for an aerospace application, um, the mass of the rotating disk is likely a major design driver. So if one solution exists that is costly on the mass side or on the weight side of things, um, that might be an important uh, data point to look at. So um, potentially I'll be enforcing a constant weight on these shape functions when looking to optimize. And then for a boundary condition, as we've done in previous homeworks, I will be fixing the disk radially at a point in the setter just so that we don't have any rigid body motion. If using abacus, I may be able to just apply some inertial relief. This is the equation for an exponential shape model that I have found online in some literature where the solution has been derived analytically. You can see in the bottom right here this plot of the radial stress as a function of radial coordinate for various values of this beta parameter. And this beta parameter describes the thickness of the outer edge describes the thickness of the outer edge of the disk relative to the inner edge. And I've just plotted in Excel here kind of what these various profiles would look like. You can imagine these reflected about the x-axis, and that would define your your axisymmetric model that would be set up in either COMSOL or Abacus. So I'll be looking at these various shape functions and um, keeping other parameters constant, potentially normalizing for mass of the system, looking at how the von Mises stress, the maximum von Mises stress is affected because it's likely that that value is what's going to be driving the design if performing something like a LCF analysis. I've also located some other literature describing other shape functions. So this is an exponential power law distribution that has two parameters. The n parameter here is similar to the beta parameter in the previous equation I showed. It just controls the thickness at the end compared to the thickness at the middle. Um, but there's an additional parameter here which controls sort of the inflection of the shape. And if time allows, this may be something also worthwhile to look into. And lastly, I've just listed some of the resources that I found so far. So that's my plan for this project. Thank you for your time.